چۆنن خوێندکارانی خۆشەویست لەم ڕۆبە دواوە هەوڵەیەم لە ڕێگەی ئەم ڤیدیۆیەوە کە لە پێیجی مارگرێت دانرێت بەردەوام بم لە وانەی ساینس. هیوادارم ئێوەش ئامادە بن بۆ ئەوەی کە درێژە بە پرۆسەی خوێندەین بێ لە ڕێگەی ئەم ڤیدیۆیانەوە. Today's class is about gravity and motion. Let's suppose you drop a tennis ball and a golf ball from the top of a tall building. Which do you think would land on the ground first? Long time ago, a philosopher named Aristotle pictured that heavy objects fall faster than lighter objects, stating that the speed at which something falls actually depends on its mass. He would explain it to anyone who would listen. His example was that an object 10 times heavier than another would have to fall 10 times faster. And no one disagreed with Aristotle. Almost 2,000 years later, a scientist from Italy attempted to prove him wrong. His name was Galileo. Galileo believed that if air resistance would be reduced, the tennis ball and a golf ball would fall at the same time. In order to prove his point, he gathered everyone in the city, climbed to the top of the Leaning Tower of Pisa, and explained the only way to prove he was right for sure was to perform a scientific experiment. He held out a cannonball and a wooden ball at the same size, and the only differences between the two objects was their mass. His conclusion was that they should hit the ground at the same time. So he leaned out over the edge, dropped both objectives, and 3 seconds later, everyone in the city saw the cannonball and the wooden ball fall at the same time, proving once for all that if there's no air resistance, all objectives, no matter how heavy, will fall at the same rate. So that was a brief history. Now, to understand the lecture, I have to mention that understanding of chapter 10 helps you a lot in understanding this chapter. Gravity and acceleration. First, let me remind you what acceleration is. It's the rate at which velocity changes over time. And about velocity, that's the speed of an object. Remember we said Galileo proved that objects fall to the ground at the same rate, right? This is because the acceleration is the same for all objects due to gravity. So let me explain it this way. We have this ball with a velocity of 0 meters per second downward. Remember you have to mention the direction. If you don't mention the direction, it's speed. But for velocity, we have to mention the direction. Anyways, so we have this ball with a velocity of 0 because it's not moving. Once we drop it, they will fall faster and farther each second than they did the second before. In the first second, we have the velocity of 9.8 meters per second downward. In the second one, we have 19.6 meters per second downward. 9.8 meters per second plus 9.8 equal to 19.6 meters per second. So can you guess how the velocity would be in the third second? Correct. 19.6 plus 9.8 is 29.4. So they increase it at this rate, 9.8 meters per second divided by second. What you get is 9.8 meters per second power 2, and that's the acceleration due to gravity on Earth. And you can calculate the velocity of falling objects with this equation. Changing in velocity equals to g times t. Now, v stands for change in velocity, g stands for the acceleration due to gravity. And remember, g always equal to 9.8 meters per second power 2, and t stands for the time the object takes to fall. We measure that in seconds. Yay, math break, your favorite part. I know guys you don't like this part, but trust me, this is really easy. So the problem says a stone at rest is dropped from a cliff and the stone hit the ground after a time of 3 seconds. What is the stone velocity when it hit the ground? Well, we can do this in two simple steps, but first remember to write the values. We all know that g equals to 9.8 meter per second power 2 and time as given in the problem is 3 seconds. Now we have to find the change in velocity. Step 1, write the equation for change in velocity. The equation is g times t. And step 2, replace the values. G is 9.8 meter per second power 2 times 3 seconds. You can remove the seconds here, and now you have 9.8 meter per second times 3. It equals to 29.4 meter per second. And ta-da! See, I told you it was really easy. Now it's your turn. You have to solve the following problems. You will find them in page 239. Air resistance and falling objects. To understand this one, bring two sheets of paper, clump one in a tie ball and the other just keep it flat. And to do this experiment, I would like to introduce you to my friend who's gonna do the experiment for us. Let's watch.
I have a cool little fun story I like doing with these papers. I'm a little weird, but let's just pretend that these papers talked. And these papers lived in Paper Town. And all of a sudden you have this big guy walking and he's like, "Gsh, gsh, gsh." And you got this small little guy walking. He's like, "Hey, what are you doing?" Nothing. Why don't you move out of my way? "Do you know who you're talking to?" "Yes, someone very big." "What?" "And very ugly." Now, of course, these papers get into this huge conflict, and then they get into this competition. They're gonna have a race. So they climb on top of a mountain. The loser has to leave town. And the race is this. This guy thinks because he's bigger, he's gonna hit the floor faster. So they climb on top of the mountain, okay? Now remember, the loser, okay, has to leave town. Now let me ask you a question. If I drop these two sheets of paper at exactly the same spot, I'm changing nothing, I'm not forcing them, I'm just gonna let them go, and the only thing that's different is its shape. They're the same exact thing, and I let it go. Which one is gonna hit the floor first? A or B? Make a prediction. And now let's see. 3, 2, 1. Was your prediction right? I think it was. The ball of paper did hit the ground first. Now, does anybody know why? Well, you see, this large sheet of paper, it was really unfair. Think about it. Underneath this large sheet of paper is what? There's air. The ball of paper had just a little bit of air underneath it to move out of the way. This large sheet of paper, as he was falling, was moving through the air like do-do-do-do, 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 where the ball of paper had just a little bit of air to move, and it kind of was like, woohoo, super fast. Now think about it, okay? That's what air resistance is. The air is resisting, there's resistance. So this paper has to move all of the air out of the way, and the bigger the surface, the more the air, the more resistance, the slower it falls.
Wow, guys, what an amazing way to explain air resistance. I guess you now know a little bit about it. So, air resistance is the force that opposes the motion of objects through air. And it depends on the size, shape, and the speed of the object. Let me clarify it on this picture. Let's suppose that we've dropped this apple from a point. The green arrow represents the force of gravity that is pulling down on the apple. If this force were the only force acting on it, it would accelerate at a rate of 9.8 meter per second power 2. But in reality, there is another force working in the opposite direction, which is the force of air resistance that is pushing up on the apple. With these two forces acting on the apple will have a net force that equal to the force of air resistance subtracted from the force of gravity. Since the net force is not zero, then the apple accelerates downward. The green arrow here is actually shorter than the green arrow before. This is because it's not accelerating as fast as it would without the air resistance. Keep that in mind that the apple fell downward when the air resistance did not equal to the force of gravity. The net force was not zero. But what happens when the net force is actually zero? As the speed of falling object increased, air resistance increased too. So the upward force of air resistance continued to increase until it equal to the downward force of gravity. Then the object falls at a constant velocity called the terminal velocity. Have you ever asked how does a parachute work? This skydiver is falling down just like any other falling object. Two forces is acting on him. The force of Earth's gravity and the force of air resistance. But as you see, the force of gravity is much bigger than the force of air resistance. So the parachute increases the air resistance of the skydiver and slows him to a safe terminal velocity. So terminal velocity happens when air resistance and the force of gravity is acting on an object. But what happens when there is no air resistance? Free fall. Free fall is the motion of an object when only the force of gravity is acting on it. Remember, only the force of gravity is acting on the object. So you can say an object is in free fall only if gravity is pulling it down and no other forces acting on it. People say that astronauts float in their spacecraft because they are weightless in the space. However, it's impossible for any object to be weightless anywhere in the universe. To be honest, it's because of free fall. To better understand it, you need to know what orbiting is. An object is orbiting when it's traveling around another object in space. To better understand this, look at this picture. This space shuttle is moving forward at a constant speed. If there were no gravity, the space shuttle would follow the path of the dotted line. The only force that is acting on the space shuttle is the force of gravity, and we can say that it's in free fall. The space shuttle moves straight down if it were not traveling forward. As a result, the path of the space shuttle follows the curve of Earth's surface. Following the path is known as orbiting. This force that causes objects to move in a circular path is called centripetal force. Gravity provides centripetal force that keeps objects in orbit. Here is the highlight of this section. Gravity causes all objects to accelerate towards Earth at a rate of 9.8 meters per second power 2. Air resistance slows the acceleration of falling objects. An object falls at its terminal velocity when the upward force of air resistance equal to the downward force of gravity. An object is in free fall if gravity is the only force acting on it. Objects in orbit appear to be weightless because they are in free fall. A centripetal force is needed to keep objects in circular motion. Gravity acts as centripetal force to keep objects in orbit. That's it for today. Feel free to ask any question in the comment section. Before I go, I want to remind you that washing your hands is one of the most important things nowadays. The best way to prevent the spread of infection and decrease the risk of getting sick. If water and soap is not available, I recommend you to use hand sanitizer. Stay safe, stay home, take care, bye!